Picture this. It's 1943. And there's this man lying on a mattress in the bomb bay of an unarmed high-speed Mosquito bomber.
Which is just a completely wild image right from the start.
It really is. So he's flying thousands of feet over the freezing waters of the North Sea, and the pilot comes over the intercom, telling him to turn on his oxygen supply.
Right, because they're flying incredibly high to avoid German fighters.
Exactly. But the man doesn't hear it. His head is literally too big for the standard issue flight helmet.
Oh, man.
Yeah, so as the plane climbs, he just passes out completely from oxygen starvation. Now, you listening might be asking yourself, is this guy a daring spy? Or maybe a seasoned commando?
Well, let's be real. He definitely doesn't sound like one.
No, he doesn't. Because he is actually a 58-year-old Danish theoretical physicist, and he is about to change the entire course of human history.
It's just such a cinematic, almost absurd situation. You've got this man unconscious in a bomb bay carrying secrets that will fundamentally shape the modern world.
Welcome to this deep dive into the extraordinary life of Niels Bohr. We have a seriously fascinating stack of sources to go through today.
We really do.
And our mission for this deep dive is to decode how a football-playing scientist not only reshaped our entire understanding of reality and the atom, but also navigated the really intense, terrifying moral labyrinth of World War II.
Yeah, and what I think is so fascinating here is how Bohr's life proves that the most abstract concepts in the universe, I mean, things like quantum mechanics or wave-particle duality, they are actually deeply connected to the most visceral human realities.
Right?
We tend to separate the chalkboard from the real world, right? But for Bohr, they were the exact same thing.
They really were. So to understand how he bridged those worlds, we kind of have to look at where he started.
Definitely.
He was born in Copenhagen in 1885. His father was a physiology professor, and his mother came from a really wealthy Jewish banking family.
So he grew up in this incredibly rigorous, privileged, intellectual environment.
Exactly. But he wasn't just some fragile academic locked in a library. He and his younger brother Harold, who was a math whiz, by the way, were passionate football players.
Oh, yeah, they loved it.
Niels was actually the goalkeeper for the Academics Bold Club in Copenhagen.
And, that willingness to physically engage with the world, to be the goalkeeper, to literally dive into the dirt, that's a pattern you see in his science, too.
Totally.
He wasn't a theorist who just sat around in an armchair. He actively wanted to test the physical limits of reality.
A perfect example of that is from 1905. There's this gold medal competition sponsored by the Royal Danish Academy of Sciences.
Right, the surface tension one.
Yeah, the challenge is to measure the surface tension of water jets. But the university didn't even have a proper physics lab at the time.
Which is crazy to think about now.
Right. So Bohr goes into his dad's physiology lab and realizes standard glass test tubes just won't work for his experiment.
So what does he do?
He actually melts and blows his own custom glassware. He shapes these long tubes with perfectly elliptical cross-sections.
Wow.
Which raises the question, why did he need to go to such extreme lengths just to measure water?
Well, it's because of the chaotic nature of fluids. To measure surface tension, Bohr needed to observe the tiny ripples on the surface of a jet of water shooting out of a tube.
Okay.
But if you use a standard, perfectly round circular tube, the water exits in a completely chaotic, unpredictable way.
So you can't measure anything.
Exactly. The ripples are completely unreadable. But Bohr deduced mathematically that if he forced the water through an elliptical opening, so an oval shape, the water jet would invert its shape at regular intervals as it fell.
Oh, creating a stable pattern.
Yes, a perfectly measurable standing wave pattern. He's actually had to invent new physical tools just to capture the invisible mechanics of nature.
That is brilliant.
And he won the gold medal for that, by the way.
Naturally. But that hands-on obsession with invisible mechanics takes a massive leap a few years later. I mean, how does a guy go from blowing glass for water jets to completely blowing up our understanding of the atom?
Well, it all stems from a profound crisis in physics at the time. By 1913, the reigning model of the atom was basically a tiny solar system.
Right. Ernest Rutherford had discovered the nucleus.
Exactly. And scientists pictured electrons orbiting that nucleus like planets around the sun. But there was a massive physics-breaking problem with this model.
Classical physics said it just shouldn't work.
It absolutely shouldn't. According to the classical laws of electromagnetism, any charged particle moving in a circle like an electron orbiting a nucleus must constantly radiate energy in the form of light.
And if it's losing energy.
Right. If an electron is constantly losing energy, it should lose its speed, spiral inward, and crash into the nucleus in a fraction of a second.
Meaning atoms shouldn't be stable?
Under those classical laws, matter shouldn't exist at all. You and I should instantly collapse into a puddle of subatomic sludge.
Okay, let's unpack this. Because Bohr sees this impossible paradox, right? And he publishes his famous trilogy papers in 1913.
Yeah, his huge breakthrough.
He essentially takes Rutherford's failing solar system model and mashes it up with Max Planck's brand new quantum theory.
Right.
He theorizes that electrons don't just orbit wherever they want, gradually losing energy. Instead, they travel in very specific, fixed stationary states.
And when they drop to a lower orbit, they emit discrete packets or quanta of energy. This explained the Balmer series, by the way.
Yes. So if we use an analogy to make sense of this, classical physics thought the atom was like a violin,
Oh, I like this.
where an electron could slide up and down the string smoothly, making any sound or taking any energy level it wants. But Bohr comes along and says, no, the atom is a guitar, it has frets.
Right, discrete steps.
Exactly. The electron is a guitarist jumping from one fret to another, producing very specific, distinct notes without ever sliding their finger in the space between the frets.
Which is such a brilliant analogy.
In fact, didn't Albert Einstein call this the highest form of musicality in this sphere of thought?
He did. He absolutely did. The notes being played in that analogy were the specific colors of light emitted by atoms, which Bohr's model perfectly predicted.
Wow.
But you really have to understand the shock waves this sent through the scientific establishment.
They weren't happy about it.
Oh, the old guard of classical physicists despised the idea. I mean, think about what Bohr was proposing. How does an electron get from one fret to the next without existing in the space between?
It's basically teleporting.
Exactly. It implied subatomic teleportation. It implied a fundamental break in the smooth, continuous reality that scientists had believed in since Isaac Newton.
But the younger generation jumped on it.
They embraced it immediately for one simple reason. It worked.
It worked. So he completely blows up the foundation of classical physics. But he realizes pretty quickly that this bizarre new quantum world isn't something you can map out all by yourself.
No, it's too big.
He needs a hub. So he campaigns the Danish government and private donors to open the Institute of Theoretical Physics in Copenhagen in 1921.
And that changes everything.
He transitions from being this solitary genius to the ultimate host of a scientific salon.
It really became an absolute magnet for the most brilliant minds of the 20s and 30s. Werner Heisenberg, Paul Dirac, Hans Kramers,
The all-stars.
literally the all-stars of physics. And Bohr created this environment where brutal intellectual debate was paired with incredible warmth and hospitality.
Like a family.
Yeah, you'd have physicists arguing equations until they were red in the face, and then Bohr would just take them all out to watch a Western movie or play ping pong.
I love that. And the discoveries coming out of that institute were just wild. My favorite example from the sources is the hunt for element 72.
Oh, the hafnium story.
Yes. So chemists have been pulling their hair out trying to classify the rare earth elements on the periodic table. There was this missing element, number 72, and everyone just assumed it was another rare earth metal hidden in some obscure dirt somewhere.
Right, that was the assumption.
But Bohr uses his new quantum model to just sit down and mathematically predict what element 72 should be, right?
He did. He mapped out how electrons filled up the distinct shells around the nucleus as elements got heavier.
Okay.
And according to his calculations, the electron shells for a rare earth metal were already completely full by the time you reached element 71.
So it couldn't be a rare earth element?
Mathematically, it could not be.
Ah.
Its outer electrons dictated that it had to be a transition metal, chemically identical to element 40.
Which is zirconium.
Exactly.
So his colleagues at the Institute, Dirk Koster and George de Hevesy, they realized they don't need to go digging in rare earth mines across the world.
No, they literally just walk next door.
They walk over to the Mineralogy Museum right next door, check some standard zirconium samples, and boom, they find element 72 hiding right inside the zirconium.
That's amazing.
And they name it hafnium after the Latin word for Copenhagen.
It was just a stunning validation of theoretical physics driving real-world chemistry. But as they pushed deeper into the math of quantum mechanics, things started to find common sense altogether.
Oh, for sure.
In 1927, experiments confirmed that matter, things like electrons, can actually behave as both solid particles and as waves of energy.
Which is so hard to wrap your head around. But that leads Bohr to formulate his principle of complementarity.
Right.
The idea that objects can possess mutually exclusive properties depending entirely on the experimental framework you use to measure them.
And this is really where physics bleeds into philosophy.
Mm.
The sources show Bohr was heavily influenced by the work of Immanuel Kant.
Interesting.
Yeah. Bohr argued that human beings are fundamentally trapped inside our classical macro-world concepts. Things like space, time, and causality.
Because that's all we know.
Right. We are forced to use our clunky classical language to describe the results of our quantum experiments, even though the quantum world operates by an entirely alien set of rules.
So we're just seeing the shadows on the cave wall, basically.
Exactly.
So what does this all mean for us? Did Bohr really say there is, quote-unquote, no quantum world, only an abstract quantum physical description?
I know where you're going with this.
Because that quote floats around a lot in popular science. Are we just making reality up by looking at it?
Well, that is a massive misconception. And we really need to look at what the sources actually dictate here.
Okay.
That famous quote, "There is no quantum world," was never spoken or written by Bohr.
Wait, really? Never?
Never. It was attributed to him years after his death by a colleague named A.G. Peterson. And when the legendary physicist Victor Weisskopf heard that quote being passed around, he was furious.
What did he say?
He angrily exclaimed, "Shame on A.G. Peterson for putting those ridiculous words in Bohr's mouth."
Oh, wow. So what was Bohr actually arguing then, if he thought the atom was real?
Bohr absolutely believed that atoms and electrons exist as physical realities. They aren't just logical constructs we invent in our heads.
Okay, that makes sense.
However, he believed that the quantum wave function, the math we use to calculate probabilities, was merely a symbolic representation.
Like a map, not the territory.
Perfectly said. It wasn't a literal picture of the electron itself. So when people talk today about the collapse of a wave function when a human looks at an experiment, Bohr wouldn't have agreed with that mystical framing at all.
Because the wave isn't a physical thing.
Exactly. To him, there's no physical wave collapsing because the wave is just our mathematical tool for understanding interactions we can't fully visualize.
That is incredibly nuanced. But this philosophical utopia they built in Copenhagen, it comes to a really violent end.
It does.
The reality of world politics intrudes. In April 1940, Nazi Germany occupies Denmark.
Yeah.
And suddenly, Bohr has to apply his massive problem-solving mind to immediate matters of life and death.
The institute completely transformed. It went from a chalkboard haven into an underground railroad for refugee scholars fleeing Nazism.
He was frantically working to secure Rockefeller Foundation grants just to get these scientists out of Europe.
He was.
Here's where it gets really interesting, almost like a spy thriller. So Max von Laue and James Franck had previously sent their solid gold Nobel medals to Bohr in Copenhagen for safekeeping.
Right.
But taking gold out of Germany was a capital offense under the Nazis.
It was a death sentence.
Yeah. If the Gestapo found those medals with German names on them inside Bohr's institute, people would be executed. So how do you hide solid gold from an invading army?
Well, you don't hide it. You fundamentally alter its physical state.
Which is just wild.
Bohr tasks the chemist, George de Hevesy, with this seemingly impossible job. And Hevesy takes the metals and just drops them into a beaker of aqua regia.
Which is a mix of nitric and hydrochloric acid, right?
Correct. It is incredibly dangerous, and crucially, it is one of the only substances on Earth capable of dissolving solid gold.
Yeah.
The acid attacks the gold on a molecular level, tearing the gold ions apart and binding them with chlorine. So slowly, these heavy, shiny Nobel metals completely disappear.
They just melt away.
They turn into an unassuming, transparent orange liquid.
And they just leave this beaker of orange liquid sitting on a shelf in the laboratory for the entire war.
Right out in the open.
The Nazis literally march into the institute, search the place top to bottom, and walk right past the dissolved Nobel medals.
It's amazing.
It is a high-stakes scientific heist in reverse. And the crazy part is how they get it back.
Yeah, so after the war ends, they take that exact same beaker down from the shelf. And by adding a specific chemical precipitant to the liquid, they force the gold ions to let go of the chlorine and bond back together.
That is basically magic.
It's just chemistry. The gold falls out of the solution as a solid powder at the bottom of the glass. And they actually ship that recovered gold back to the Nobel Foundation, who restruck the original metals.
It perfectly captures Bohr's practical ingenuity. But the occupation also brings one of the most mysterious and heavily debated moments in the history of
Oh,
science.
the Heisenberg meeting.
Right, his September 1941 meeting with Werner Heisenberg. So Heisenberg was his former star protege, but now he was heading up the German nuclear weapon project.
Yeah, a very tense dynamic.
They take a private walk outside the institute, and whatever was said severed their relationship permanently. But wait, the sources totally contradict each other here.
They really do.
Heisenberg is running the Nazi bomb project. Was he bragging about a weapon or secretly trying to orchestrate a mutual strike among scientists? Like, how do we even know who to believe?
It is a profound historical mystery.
Mm-hmm.
And to look at it impartially, we have to examine the conflicting records very carefully.
Okay.
In 1957, Heisenberg claimed in a letter that he went to Copenhagen to warn Bohr.
To warn him.
Yeah, he suggested his goal was to communicate that a bomb was theoretically possible, but technically exhausting. And he wanted to discuss the moral responsibilities of scientists on both sides.
So kind of hinting at a secret agreement to stall research.
Essentially, yes.
Yeah.
That was Heisenberg's later claim.
But Bohr didn't interpret it as a peace offering at all, did he?
Not in the slightest. When Bohr read Heisenberg's account years later, he drafted multiple letters back to Heisenberg. Letters he actually ultimately locked in a drawer and never sent.
Oh, wow. Why?
Probably because of how raw the emotions were. In those drafts, Bohr stated he was deeply shocked by that 1941 meeting. His firm, undeniable impression was that Heisenberg was pushing for Danish cooperation with an inevitably victorious Germany.
That's chilling.
Worse, Bohr came away convinced that Germany was vigorously pursuing atomic weapons under Heisenberg's leadership, and that Heisenberg was totally confident they would succeed.
So Bohr saw no subtle hint of a mutual strike.
None. Only a chilling reality check.
And the reality only got darker from there. By September 1943, word reaches Bohr that he and his brother Harold are going to be arrested by the Gestapo because of their Jewish heritage.
Yeah, time was up.
The Danish resistance manages to smuggle Bohr and his wife to Sweden by sea under the cover of darkness. But Bohr doesn't just go into hiding once he's safe.
No, he immediately takes action.
He requests an audience with King Gustav V of Sweden and pleads with him to broadcast a public offer of asylum to Jewish refugees.
And this intervention is absolutely crucial. On October 2nd, Swedish radio publicly broadcasts the asylum offer.
Wow.
This directly precedes the legendary mass rescue of the Danish Jews, where over 7,000 people were smuggled across the water to Swedish safety.
That's incredible.
And while historians debate his exact level of solitary influence on the king's decision, his courageous intervention at the highest levels of government was undeniable.
And that brings us right back to our opening image. Britain desperately needs Bohr's mind. So they strap this 58-year-old genius into the bomb bay of a de Havilland Mosquito.
Right, the flight where he passes out.
Yeah, because his head is too large for the helmet, he misses the radio call, passes out from lack of oxygen over the North Sea, and only wakes up when the plane descends over Scotland.
He nearly dies, just to join the Allied war effort.
So from Britain, he is quickly brought into the Tube Alloys nuclear project, and then shipped across the Atlantic to consult on the top-secret Manhattan Project in America.
Where he ends up at Los Alamos under the alias Nicholas Baker.
Just walking around the desert with his son, Age.
Yeah. And J. Robert Oppenheimer called Bohr a scientific father figure to the younger scientists who were cracking under the immense pressure.
But what was Bohr actually doing there? Because he wasn't building the whole bomb from scratch. Right?
No. He was brought in to solve highly specific, stubborn bottlenecks. One major contribution was his work on the bomb's modulated neutron initiators.
Which is essentially the spark plug of the atomic bomb, right?
Precisely. So you have this core of radioactive material that you are crushing with conventional explosives to create a nuclear chain reaction.
Okay.
But for the chain reaction to actually ignite, you need a massive sudden burst of loose neutrons injected into the core at the exact microsecond of maximum compression.
And the device that creates that burst is the initiator.
Exactly. Bohr's deep, unparalleled understanding of nuclear dynamics helped the team refine the complex timing and geometry required to make that spark plug work flawlessly.
But as Bohr famously noted, he said, quote, "They didn't need my help in making the atom bomb."
Yeah, he knew they'd figure it out.
His real focus, while everyone else was obsessing over the blast radius, was on the terrifying post-war reality that this weapon was about to create.
He shifts from scientist to political prophet, essentially.
He does. He tries to convince U.S. President Franklin D. Roosevelt and British Prime Minister Winston Churchill to share the Manhattan Project's secrets with the Soviet Union before the war ends.
Which was a very bold move.
Yeah, I have to ask, wasn't it incredibly naive for a theoretical physicist to walk into a room with Winston Churchill in the middle of a world war and essentially ask him to hand over the ultimate weapon to the Russians?
Well, if we connect this to the bigger picture, it wasn't naive at all. It was actually terrifyingly prophetic.
Yeah.
Bohr's entire life was dedicated to understanding the mechanics of cause and effect. He knew with absolute scientific certainty that the physics of the atom were a law of nature.
Right.
And you cannot keep a law of nature secret forever. He knew the Soviet Union would eventually figure the physics out and build their own bomb.
So secrecy was pointless.
Worse than pointless. By trying to maintain a monopoly through secrecy, Bohr argued, the Allies were guaranteeing a paranoid, catastrophic Cold War arms race.
Oh, wow. And Churchill was completely furious at the suggestion.
Explosively furious. Churchill could really only view the world through the lens of traditional military supremacy.
Right.
He wrote a scathing letter afterwards saying that Bohr, quote, ought to be confined or at any rate made to see that he is very near the edge of mortal crimes.
Mortal crimes, that's heavy. But Bohr didn't let Churchill's threats stop him. Even after the war, in 1950, he writes an open letter to the United Nations begging for an open world and international cooperation on nuclear energy.
He never gave up on that.
He leverages his fame to help found CERN, bringing European physics back together, and helps establish Nordita. His contributions were so profound that in 1947, the King of Denmark conferred upon him the Order of the Elephant.
Which is an honor normally reserved strictly for royalty and heads of state. It's completely unprecedented for a scientist.
And part of receiving that honor meant he had to design his own coat of arms to hang in the royal chapel.
Right.
He chose a design featuring the ancient yin-yang symbol and the Latin motto, Contraria sunt complementa. Opposites are complementary.
It really is the ultimate summation of his life's work. The wave and the particle. The deep existential dread of unleashing a nuclear weapon paired with the absolute driving necessity of striving for global peace.
To summarize this for you listening, Niels Bohr wasn't just a man who figured out how electrons jump between orbits.
No, he was so much more.
He was a man who constantly sought harmony in contradictions. He proved that you can be a rigorous, math-obsessed scientist and still have the moral courage to defy the Nazis, orchestrate the rescue of refugees, and stand face-to-face with Winston Churchill.
And I think the profound takeaway here for any of us trying to learn about the world is that true understanding isn't about choosing between either.
Right.
Reality is rarely that clean. Bohr teaches us to embrace the complex both hand. When you find two truths that seem to violently contradict each other, you might just be on the verge of discovering a much larger, previously invisible framework.
I love that. I want to leave you with one final, slightly provocative thought that we haven't touched on yet.
Well, let's hear it.
Where did this revolutionary ability to hold two contradicting thoughts come from? Did the foundations of modern quantum physics actually stem from a 19th century angst-ridden philosopher?
Oh, the Kierkegaard connection.
Yes. The sources note that way back in 1909, Bohr sent his brother a birthday gift. It was a book called Stages on Life's Way by the Danish philosopher Søren Kierkegaard. Okay.
Bohr told his brother he disagreed with Kierkegaard's religious advocacy, but he absolutely devoured his literary style and thought processes.
Interesting.
Historians still debate the exact influence today, but is it possible that Kierkegaard's existentialism, his intense focus on subjective experience and the inherent paradoxes of human life, subconsciously planted the seed for the principle of complementarity?
That is wild to think about.
It's wild to ponder if the most advanced world-breaking science of the 20th century was actually sparked by philosophical poetry.
It raises such a fascinating question about where our ideas really originate. I mean, inspiration rarely stays inside the neat, classical little boxes we try to build for it.
Just like a 58-year-old physicist doesn't belong in the bomb bay of a Mosquito plane.
Exactly.
But sometimes the man whose head is too big for the helmet is the only one who can carry the universe inside it. Thanks for taking this deep dive with us. We'll catch you next time.